All right, let's talk about something that's absolutely critical for any AI system, but honestly, it gets overlooked all the time. I'm talking about trust. And not just, do you trust the AI's answer? I mean trust in the very foundation it's built on. Because what happens if that foundation is shaky from the get-go?
So let me ask you something straight up. What is really inside that AI system you're building or using? I mean, sure, you know your code, you know the model's architecture, but do you really know about the hundreds, maybe even thousands, of open source packages that everything is resting on?
And, this quote just hits the nail on the head. We spend so much time worrying about a model's bias or its accuracy, right? But the real risk, it starts way, way earlier. It's buried deep inside that tangled mess of software dependencies. That's the invisible threat we're going to unpack today.
Yeah, that invisible web, that's what we call the AI supply chain problem. And look, before we can even think about solving it, we first have to get a handle on just how big this hidden challenge really is. Think about it like this. Over here, you've got your code. It's the part you wrote. You know it inside and out. But then, you've got this, the reality, a gigantic, messy web of code someone else wrote. It's like you've designed this incredible, beautiful skyscraper, but you're building it on a foundation made of concrete and steel that you've never even bothered to inspect. The whole thing, your entire creation, is resting on a foundation you just have to hope is solid. So, the big question is, how do you actually inspect that foundation? Well, that's where a tool built for this exact problem comes into play. It's called DEP.KEYSTONE. And its whole purpose is right there in the name: deterministic dependency verification and supply chain attestation. Okay, that's a mouthful, so let's break it down. Deterministic just means it's predictable, it's repeatable. You run it on the same stuff, you get the exact same result every single time. And attestation? Well, that just means it gives you proof, a formal, verifiable record that the inspection actually happened.
Okay, so how does this thing actually measure trust? It's not just a simple pass-fail, a thumbs up or thumbs down. It gives you a number, a quantifiable metric they call a trust score. And that score paints a really clear picture of your project's risk level.
What you're aiming for, the absolute goal, is a perfect 100 out of 100. A perfect score means your dependency graph is totally pinned and clean. In plain English, that means every single piece of code you're relying on is locked to a specific, known version, and there are no other known risks. It's basically the gold standard for a secure foundation. And the best part is, this score isn't some black box magic. It's calculated using a totally transparent, weighted system. See, every issue it finds gets a severity level, and each level has a specific point deduction. Just look at this. A single critical issue, boom, that knocks a whopping 40 points right off your score.
The math itself is super simple. You start with a perfect score of 100, and for every problem it finds, you just subtract the points for that issue's severity. That's it. What you're left with is a really clear, easy-to-understand score that tells you exactly how risky your project is.
So what kind of issues are we actually talking about here? Well, let's look at a couple of examples. Take DEP-001, an unpinned version. This is a medium risk, right? It means you've told your project, hey, just go grab the latest version of this package. Sounds harmless. But what if that latest version has a brand new, zero-day vulnerability in it? You just automatically pulled that risk right into your system without even knowing. Now, let's contrast that with something like DEP-006, a known typosquat pattern. Whoa, that is a critical risk. That means the tool thinks you've installed a malicious package that's just pretending to be a real one. It's a deliberate trap set by an attacker. So you see, these aren't just theoretical problems. These are real-world threats that can bring down your whole system. Okay, so the tool runs, it gives you a score, then what? What's the output? Well, you get this thing called the Trust Certificate Bundle. And this bundle is basically your official proof of verification. See, every single time you run a verification, the tool generates these 3 key files. They're often called artifacts in the dev world. The best way to think of them is like a neatly packaged set of digital receipts that prove exactly how healthy or unhealthy your supply chain is. And each of these files has a really specific job. First, you've got the JSON report. That gives you the trust score and a detailed list of all the findings. Then you have this SHA-256 hash. That's your deterministic attestation anchor. It's basically a unique digital fingerprint of your entire dependency graph. If a single bit changes anywhere, that fingerprint changes. And finally, you get a standards-compliant software bill of materials, an SBOM. Think of it as a complete ingredient list for your software.
Put them all together, and these artifacts are absolutely perfect for things like audit trails, for procurement teams to do their checks, and for automating security right inside your CI/CD pipeline.
So, let's put this all together. Having this bundle of proof, it's not just about good coding habits for developers. No, this is much bigger. It's about creating verifiable trust across the entire organization. And this is where it gets really, really important for any serious organization. Using a tool like this isn't just a nice-to-have best practice. It actually helps you line up with major industry and federal standards. We're talking about things like the NTIA's SBOM requirements, cybersecurity executive orders, the NIST AI risk management framework, the whole shebang. It takes supply chain security from being just a suggestion and turns it into a process that is compliant, auditable, and frankly, defensible.
Which really just leaves us with this one final thought to chew on. As AI gets more and more powerful, as it gets woven into everything we do, the question isn't just going to be, do you trust it? The question is going to be, can you prove it's trustworthy? And that proof? It has to start at the very, very bottom, with the foundation everything else is built on.